Thanks very much, Peter. This is a great honor to be here. I'd also like to thank AGU, all the colleagues and students who I've worked with, and the American taxpayer for funding my work. This talk is also going to be in the theme of science and society and impacts of science on policy. You want to start the clock? So this is our beautiful planet, but after a nuclear war, it might look like this, with a cloud of smoke covering the planet, absorbing the sunlight and making it cold and dark and dry at the Earth's surface. The theory of nuclear winter is very simple. There would be targets that would be cities or ground bursts, which would produce smoke or dust, which would absorb or reflect sunlight, meaning very little sunlight would reach the ground, then it would rapidly cool, and this is what we call nuclear winter. And if there was enough, it could cause devastation for agriculture and a catastrophe for humankind. This is a graph of the number of nuclear warheads on the planet, and work done jointly by Soviet and American scientists in the early 1990s gave the same message to policymakers that this would be a catastrophe. And then I wrote a paper the next year in Nature along with Steve Schneider's group. Turco et al., by the way, includes Tom Ackerman, who's here and who just gave a talk, and Brian Toon, who's here. And then the nuclear arms race ended and the number of weapons started going down. And it wasn't caused by the end of the Soviet Union. The Soviet Union didn't end till here. You also might note that is this the pointer? That the number of nuclear weapons during the Cuban Missile Crisis in 1962 was almost exactly the same as it is today. But back then we didn't know that it would produce a nuclear winter. Why do I think that this message from scientists helped to end the arms race? Well, you can ask Mikhail Gorbachev. He was interviewed in 1994. How did he feel when he got control of the Soviet nuclear arsenal? He said, perhaps there was an emotional side to it, but it was rectified by my knowledge of the might that had been accumulated. 1,000th of this might was enough to destroy all living things on Earth, and I knew the report on nuclear winter. And in a 2000 interview, he said, models made by Russian and American scientists showed that a nuclear war would result in a nuclear winter that would be extremely destructive to all life on Earth. The knowledge of that was a great stimulus to us, to people of honor and morality, to act in that situation. The work I'm going to talk about is the most important work I've done in my life and what I've done a lot of in the next 5 years. And these are the colleagues that work with me on it: Luke Oman, Gira Stanchikov, Brian Toon, Chuck Bardeen, Rich Turco, and Lily Hsia. This is a graph of the number of nuclear weapons on the planet as a function of time. And you can see this red line is one new country for every 5 years. And there are 9 nuclear nations on the planet, and it's more than just these established nuclear powers. At an AGU meeting here 6 years ago now, Brian and Rich walked up to me and said, we were calculating how much smoke would come from a war between India and Pakistan using much less than 1% of the global nuclear arsenal. And Luke and I then did climate model simulations of that. Here's the number of weapons on the planet, and Russia and the U.S. still have about 10,000 each. If you look at how much smoke would be generated by dropping 50 Hiroshima-sized weapons on the major targets in different countries, this is how much smoke, millions of tons of black carbon, and these are the nuclear weapon states. And so we did a model. We took this amount of smoke from India and Pakistan and put it into the model. We actually were conservative. We used 5 teragrams of smoke. It would be a terrible tragedy. 20 million people would die, but there would be smoke injected into the upper troposphere actually after accounting for fuel loading and emission factors rain out. And we used the GISS GCM, Dorothy Koch's code for aerosols. And here's a movie of where the smoke would go. And this is from one of the runs that we did, it would spread around the world. Within a week or so, most of the planet would be covered. I'm going to show this again, and on the left I'll have a graph of the vertical distribution, and you can see that it gets lofted up above the tropopause within 2 or 3 days, and it ends up with an e-folding lifetime of about 5 years, much longer than for volcanic aerosols, which have a lifetime of only about 1 year. And so we calculated the climate response. This is the global average temperature response, and temperatures would go down by about 1.25 degrees Celsius for several years. This is with a coupled atmosphere-ocean GCM. And the forcing at the bottom, the blue line is for a Pinatubo simulation, and the black is for this. The forcing would be much larger and last for much longer. And on the block on the right is precipitation. Global precipitation would go down about 10%. So this would not be a nuclear winter, but it turns out it would be, if you plot it now on the curve we know and love of global warming, it would plummet us much colder than little ice age conditions very quickly. This would be global climate change unprecedented in recorded human history. If you put it on the hockey stick diagram, it would be colder than the little ice age. The upper atmosphere would be heated, and this is the change in temperature of the atmosphere, more than 50 degrees Celsius warming, and of course this would have an influence on stratospheric chemistry. And this is results of Mike Mills, who's here, and Brian Toon, showing that for this case, for India-Pakistan nuclear war, much less than 1% of the nuclear arsenal, you would reduce ozone globally to ozone hole levels for years. And Mike's done some recent work that shows the effects would be even larger in temperature than I showed you just here, if you account for the ozone feedback. If you look at the spatial distribution of temperature, the cooling would be larger over the land in the summertime, several degrees. The ocean wouldn't cool as fast. And precipitation would go down. And so we said, well, and the growing season would be shorter by several weeks. So we decided to look, this is very recent work just submitted to Climatic Change. How would this affect agriculture? So I worked with Mutlu Özdogan, and we put these scenarios of this change of temperature, precipitation, and sunlight into a model that calculates the productivity of corn and soybeans in the Midwest United States. And the productivity will go down by about 15 to 20% for a decade. This is corn, this is soybeans. So our source of food is the grocery store, and if people stopped trading food, it would be a real catastrophe, not just the immediate effect, but the effect on trade. And then Lily and I did a study where we looked at rice production in China with a different agricultural model, and for the first 3 years, there would be a 25% reduction of rice production in China, and averaged over the 10 years about a 15% reduction of rice. We took this new good model and we said, let's go back and do a calculation of nuclear winter. Back in the day, there was always a question, was it nuclear fall, was it nuclear winter? And so we did the simulation with 150 teragrams of smoke, which was the baseline simulation back then, but it's also what could be produced today, because then we had to use 9 weapons on every target because they ran out of targets. And this is a simulation of where the smoke would go, and for 150 teragrams of smoke, and the temperature change would be huge. This is the change in the first year, and let's look at the Ukraine, and the red line, the black line is the normal seasonal cycle from the control run. The red is what you would get after this 150 teragrams, and indeed the temperatures would go below freezing for more than 2 years. So really it is nuclear winter in the middle of continents. And we did a scenario for 50 teragrams, and this is the 5 teragram one I showed you. It's very nonlinear because once you get a lot of smoke, there's not much sunlight to reflect back, to stop. If you plot these 3 curves on the global warming, this is how much temperature change you would get, or on the hockey stick diagram. And we can still produce this with our current arsenal, and the arsenal by the end of the New START Treaty will still be able to produce nuclear winter. So what's new? A nuclear war between new nuclear states using much less than 1% of the current nuclear arsenal could produce climate change unprecedented in human history. Nuclear winter theory was correct. The current arsenal can still produce nuclear winter. And the effects of a regional or global nuclear war would last for more than a decade. We never knew that before. We only knew that by running a model with a stratosphere and mesosphere. There are many analogs, which I don't have time to talk about, we can't test this theory in the real world, so we can look at day and night, the seasonal cycle, fires, and smoke and dust, and volcanic eruptions as analogs. So Obama and Medvedev signed the New START Treaty last year in April, pledging us to go down to about 4,000 weapons total by 2020. 2017. But as Carl Sagan said, elementary planetary hygiene demands many fewer nuclear weapons much more quickly than this. That will still be at danger even with that reduced number. So a year ago, I was invited to go to Cuba. Fidel Castro became interested in my work, and I gave an hour-long talk on nuclear winter with him sitting in the front row, and that's his signature of the photo that he gave me. And then he presented me with his biography, the autobiography which he'd just written. And then the next day at the Hotel Nacional, this envelope showed up from Commander-in-Chief Fidel Castro Ruz for me with a photo that was taken, signed by him. And so I'm going to Cuba. What's that? I'm going to Cuba next week on a trip sponsored by AAAS, and I'm going to talk to them about having a conference in October there, the 50th anniversary of the Cuban Missile Crisis, and we'll invite all the foreign ministers of the nuclear nations and explain to them that you've got to get rid of the nuclear weapons much more quickly than we're doing now to save the planet from this danger. And I hope that this will work. You'll find out about it next year, and keep our planet looking as and after I talked to Fidel, 9 days later, he said, while the United States and Russia each committed to reducing their operative nuclear arsenals down to some 2,000 weapons in April 2010 in Prague, the only way to prevent a global climate catastrophe from taking place would be by eliminating nuclear weapons. And I hope the rest of the world will agree to this soon. Thanks.